In the last topic of Chapter 3, Section 5, and our next class will be having a test on what we've done so far, and you will be allowed to use your notes, but you prepare for the test by doing your homework, study plan, whatever is needed, and getting your mastery. And the questions we'll have on our test will reflect the kinds of things we have been doing in class and, of course, in your study plan and homework. So with that, let's go on to analyzing arguments with Euler diagrams. Now, I would have pronounced that Euler, but I've heard others Euler. I guess it's a German way of pronouncing that. So, in reflection, as I looked through this section, I wondered, well, how does this relate to real life? Well, if you've ever watched a court drama where there are lawyers and they're presenting arguments, they're looking at evidence and then they're saying the truth of this in the evidence is supported then by some outcome, which is guilty or not guilty beyond a reasonable doubt. So lawyers study this. I know when I taught biology, we often use this. One of the points in every write-up of a lab was, what are your conclusions? Again, based on the data you developed as you did the experiment, and then how does that rate to your original hypothesis? I haven't seen that word here, but it's implied in many cases. The assumption is sort of like a hypothesis. So, as we look at this, logical argument is made up of a premise or premises, which include the assumptions that you may have assumed things that you're saying are true, the laws, rules, widely held ideas, and observations. Now, once you have this data, you then make a conclusion. And we recall, and we didn't cover this particularly in this course, but deductive reasoning, that this follows from that is deductive reasoning. You then make the conclusion based on arguments whether or not something is valid. So if the argument is valid, that is, all the premises are true, we say it is valid. If the premises, some of them are not true, then the argument is not valid or is invalid and is called a fallacy. Again, these are more technical uses of the words. Sometimes these things are thrown around very loosely. Now, valid and true do not have the same meaning. An argument can be valid even though the conclusion is false, or invalid even though the conclusion is true. We'll see this in some of our examples. And there's a picture of Euler. Again, I would pronounce that Euler. I don't care how you pronounce it, but that's what I've heard, Euler. Now, arguments with universal quantifiers, quantity, all, everything, these are often challenging to support whether they're true. Because if you say all of something, you're painting something with a very broad brush, as opposed to picking out things. It sort of deals with, in everyday life, stereotypes. All of somebody is this way. And we won't get political here, but we'll pass it up. Anyway, so there is the pronunciation Euler, and he's one of the most famous mathematicians. He is the one who developed an irrational number lowercase e, which is named in his honor, after his last name. This number appears throughout mathematics. We'll go over it in chapter 6, which is the next chapter we'll be doing. We're skipping 4 and 5, and in chapter 8. So let's take a look at this. So we want to use in example 1 an Euler diagram to determine the validity of this. So is the following argument valid? No accidents happen on purpose. Spilling the beans was an accident. The beans were not spilled on purpose. To begin with, what we do is we draw a region to represent the first premise. No accidents happen on purpose. So there's the accidents. Now, because no accidents happen on purpose, the region for accidents goes outside the region of things that happen on purpose. So these are things that happen on purpose. These are accidents. Now the second premise, spilling the beans was an accident, suggests that spilling the beans belong in the region representing accidents. So we're going to put an X there. Spilling the beans is not the region for things that happen on purpose. If both premises are true, the conclusion that the beans were not spilled on purpose is also true. So the X is where it should be in accidents. Therefore, the argument is valid. Now, looking at example 2, using an Euler diagram to determine validity. All right, our first statement: all rainy days are cloudy. Today is not cloudy. Today it is not rainy. So in figure 10 here, we're going to put our big outer region as a cloudy day, and in a sense a subset, although they're not using those words, we used them earlier. Rainy days would be inside the cloudy days. Now, that it is not rainy, where do we put that X? Well, we're going to put it outside. So, these are true, and this is true. Therefore, the two premises are true. The argument is valid. Now, if you've seen the court cases on TV, you'll notice often the jurors are taking notes. And you might say, why are they doing that? Well, they are writing down the data, and they'll want to consider their verdict based on things, or things they want to bring up when they are deliberating in the jury room. Okay, let's take a look at this one. All magnolia trees have green leaves. That plant has green leaves. That plant is a magnolia tree. Well, again, your super circle in the Euler diagram is that things have green leaves. Now, as a subgroup of that, the magnolia trees fit within that group. But then the question is, where do you put the X? That plant is a magnolia tree. It could be inside there, or it could be outside of it. You don't know. So the premise may be true or may not be true. Because of uncertainty, we cannot accept the conclusion as true. Thus, the argument is invalid. It is a fallacy. So as we follow in example 4, is this argument valid? All expensive things are desirable. All desirable things make you feel good. Again, by definition, if it's desirable, then you sort of apply that. All things that make you feel good make you live longer. That may not be true, but it might be true. All expensive things make you live longer. Now, as you set up your Euler diagram, you see that expensive things lie in the center. So using the logic, we say the argument is valid, but the conclusions that you make out of this need not have or may not be true. So, for instance, alcohol may make you feel good, drugs may make you feel good, but they definitely don't make you live longer. So, again, using the quantifier all, that's where, you may get a good argument, but may not be true. Again, tying this into a jury trial, within reasonable doubt. What would the reasonable average person conclude? And that's what the lawyers play on. Now, as I look at example 5 here, using an Euler diagram to determine validity, we think about these a lot. Common knowledge, common sense, and here we're just applying what we might do in our normal lives to this symbolic logic and trying to get an idea how, lawyers and others who have to make decisions may operate. So is the following argument valid? Many students drive Hondas, and that may be true, because you're not saying all here, but many. I am a student. I drive a Honda. So in our first circle, we're going to make people who drive Hondas. This would be a major group. A subgroup of it would be students. Not all people are students, but there is a connection. Now, where do I put the I, which is myself, the student? Do I drive a Honda or do I not? The uncertainty of where you would place the I makes this argument invalid. And again, more detail there. Okay, as we look at this next example, it's pretty straightforward. And we are missing the question. This is better. Is the following argument valid? All fish swim. All whales swim. A whale is not a fish. So the premises lead to two possibilities. This is figure 16 and this is figure 17. Now here we have the larger Euler circle swimming things. And we have fish and we have whales, and they are intersecting the whales with the fish. Well, you can see a biologist didn't write this because whales are not fish, so there shouldn't be an intersection. But let's go along with it. They're thinking fish, anything that, looks like a fish. And then the other is swimming things, and here they do have them separated. Now, since the X, a whale is not a fish, is here and not here, again, you're looking at what would be your final argument. And this is what the authors of our text conclude. Because the truth of the premises does not force the conclusion to be true, the argument is invalid. Even though we know the conclusion to be true, this knowledge is not deduced from the premises. Now, another little biology thing I might add here is that starfish are not fish. They do swim. And again, an argument, depending upon what you know, and if you are a juror and you don't have the background to make a decision on something like this, then really I think it's by law you should excuse yourself from serving. Or if you have preconceived ideas, we want the juror to get in there to be knowledgeable and able to be objective. Again, these are some words we haven't used yet, but you may or may not be familiar with. Now, when I'm preparing these videos, it's before the election. Today is the 29th of October, so the election is just over a week and a half away. But we're doing this in January, February. So for further thought, I thought we'd spend some time. So we'll have folks read this, and then we'll have some commentary reflecting on some common fallacies. So let's pause. Okay, hopefully we've had a chance to go over some of these. one that I would add for number 3 here is that a lawyer asks someone on the stand, "Do you beat your wife?" And he wants an answer, yes or no. So if you say yes, of course, then you beat your wife. If you say no, he is implying that you may be lying, and in the context of you're beating your wife, you're planting a thought in the juror's mind that you may have beaten her. So the questions that you ask can be what are called loaded questions. And this was a good example too. I could remember post hoc reasoning is one of the ball teams sometime in the past. You wondered why they all had beards. I think it was the Red Sox, yes. They would grow a beard, and why were they all wearing beards? Well, because one didn't shave that day, and he got a hit, and the superstition, in a sense, went around that by wearing a beard, that was the good-like thing, and sometimes, that's what it is. And here's someone wearing a certain shirt or a certain pair of shoes or a certain color underwear even, maybe whatever that spiritual, psychic thing that may be out there that causes you to move in one direction. I don't know if you heard the word talisman there. Some little amulet or something that you can have a rabbit's foot years ago. If you had a rabbit's foot, that was good luck. Was it good luck for the rabbit? All right, let's go on. Well, there are a few more on the next page, which are very good, and we'll have time, so let's go over these a little. The red herring, shifting the burden of proof, and straw man. For group and individual investigation, well, we don't do term papers, but if we did, these might be good topics. All right, well, this will wrap this up, and we'll do some exercises here that are on the next page as well. And we'll have our books, and we'll do some of these.